Hey everyone, I'm going to make a quick video here. I'm going to try to keep it quick because this is the fifth time I've tried to make it. Somebody keeps calling me. And this video is on the subject of using Raspberry Pi Pico Ws to do bilateral communication between two identical devices. Now there are tutorials out there already for communicating between a Raspberry Pi Pico and a desktop PC or an Android device through the web browser. You can control your garage door and stuff like that. But this is for communicating between a Raspberry Pi Pico here and another one which is over here connected to my desktop PC. So we've got two computers, two Raspberry Pi Picos. Now, the PC is not an important part of the picture here. We're just using that to monitor everything and make it easy using the Thonny. But you could have the Raspberry Pi Pico not connected to the desktop PC and it would still be able to do communication. And what we're going to do is we're going to send arbitrary strings between devices, okay? And there's a fair bit of latency at this point, but it's not that bad. Okay, so I think you get like half a second of latency or something. But okay, so let's stop both devices. Then I'm going to start the programs. I'll narrate what happens in the programs. And then you can see for yourself. Oh, what's up? Sometimes this happens. Sometimes the client device doesn't want to restart in Thonny very well for some reason. Okay. Now I know this might seem like a long video, and also I'm not bothering to edit it much. But the truth be told, if you are trying to actually make something, you don't care about that stuff very much. What you want is those details, and this is going to save somebody a lot of time when you're actually going to actually do the actual thing. So that's not very stylish. That's not the way things are normally done in society, but I think it's a good way of doing things. Okay, so I start this device. This is the host device. This one is the host in terms of the TCP socket connections, and also when it cannot connect to the programmed Wi-Fi network, then it starts the access point. So it is also the access point device. So it's the master in both contexts. So it tried to connect here. It said waiting for connection. That was trying to connect to this access point, this name, this password. So you're going to have to enter that for your own. And if it can't do it, then it starts its own access point. And now it's listening for the host. But the host is not even powered on yet. So that's why it's not, it's giving all these error messages with the timeouts, right? Now it gives you these baffling error messages, error no 11 e timed out. Now that makes some sense, but sometimes it gives you other messages that don't make any sense. There's ebadf, which means it's basically the error is propagating down. Something goes wrong earlier on, but it doesn't actually show up until later. And by the time it shows up, it says ebadf, which means bad file. And there's some of the stuff like that happens. Again, you have to remember that you are only sending strings. You can't send an integer. If you want to send an integer, you have to convert it to a string and then convert it back from a string at the other end. If you try to do that, it's going to give you error messages and stuff. Hopefully somebody who's a little bit more clever with the programming can add some error handling or something, or just convert everything to a string before it gets sent. But, okay, so what's going on here is that it says stuff sent from host. And then it says message received, test from client. Okay, and over here, the message received is send from host. This is the client device we're looking at. So it's receiving a message from the host. And the message apparently sent is test from client. So, I mean, the messages match. Everything's working. The communication is occurring. And is occurring at whatever frequency. You can see that the printout is changing here. So that there's no artificial delays in here. So that is looping around and connecting and sending stuff as fast as it can. So your latency is going to be about that. I don't know, I think maybe it's going at 2 or 3 times a second. It's communicating. However, if you want to send a large string or something, it's not going to be that slow. It's like you get a high bit rate, but it's going to be significant latency because it takes time to set up the connection. But you still get a high bit rate because you are connected over Wi-Fi. So you can see it works. The code is going to be on the Google Drive, and I will link to it from the YouTube comments section or the description of the video. And let's just take a moment to go through the code, and I'll tell you a little bit about how it works. You need to know that the host device has a static IP, and the client device has to know the IP. Okay, there's no way of using host names or whatever or DNS right now that's reliable. There are methods of doing that, but it's not very reliable. So hopefully somebody could cook something up, but I didn't really want to look into that stuff because it's not very reliable anyway, and I need a reliable system. It works on some networks and not others and stuff, and I can't be shipping stuff that's not going to work sometimes. So now the IP address for the AP, the access point, is not the same as for the IP address when it is connected to the regular Wi-Fi network. If they're both connected as clients to the Wi-Fi network on the Wi-Fi level, then the host device will get this address here, okay? But if this device here is an access point, then it can only have one IP address. Unfortunately, you can't actually change the address, apparently. You can try, and it says it changed it, but then you still can't communicate with it for some reason. So I haven't figured that out yet. And this is the access point, the backup AP IP. So, yeah. This code will work by default, but if you encounter any complications, that's a prime suspect. Now it always works on port 80. I mean, that's sort of hard coded in there. You could go through the code and change that if you want to, but that's just a good one because the firewalls always allow that through because it's the same port as HTTP for web browsing. And so basically we've got all these functions here, but it connects to the Wi-Fi, and then the IP address is returned. If the IP address is 0, that means the connection wasn't made. You're going to make an access point, and then you're going to you can open a socket, return the connection object with the socket produces, and then you're going to stuff that into the receive send function. The receive send function has a loop in it, so it starts and then it just loops around forever, trying to listen for messages and then send messages. The messages are stored in global variables. So when you want to send a message, you're going to just change the send buffer. It has to be a string, remember. When you want to receive something, you're just going to read the receive buffer. And to know that it is received recently, after you read the buffer, you should set the flag to 0. And then when the communication system receives something, it will set the flag to 1, so that you know that it's fresh information. Okay, otherwise you might be reading the same stuff as you were last time. So you could have two identical messages, or you could be the same message as last time. And then the same deal with the send buffer flag. When you send stuff, it'll send it to 1 automatically when stuff has been sent. When you check that, you'll know that stuff has been sent. If it's 1, if it's 0, well, stuff hasn't been sent. Not recently anyway. So yeah, it mostly works. You're probably gonna have to change this anyway, so there's no point in polishing it up. The two things to do in the future would be to, one, you can experiment with tuple assignment, for instance. You would stuff various variables into a tuple, and then you would convert them to a string, and then you'd send the string, and then convert the string back to a tuple, and then use tuple assignment to assign the variables back again. That way you can transfer information from one pico to the other directly from variables in one program to the variables in the other pico inside the program. Right? Very direct connection, no messing around. You don't have to parse anything. One of the great things about Python is that you can do that, right? Like you don't have to have any kind of complicated method of parsing out information, putting it back together again. And yeah, so that's pretty handy. In fact, one thing I wanted to try was just using the eval function. So you send a string, which is like a command. It can be anything. It can be a line of code, and then you would run it at the other side. So you can run a function remotely, basically. That would be kind of cool. Obviously, you have to be careful about doing that because there would be massive security implications. Anybody could run any code on your Pico if they got access. but this isn't a very sensitive piece of equipment. So I'm just going to go over the code one more time and then I'll post it up. But you can see it works okay. We've got here, it stops working. Okay, sometimes when, for some reason the device stopped working. About to try to connect. Entering host socket listen. So this one is listening. This one is trying to connect. But it's not connecting for some reason. So usually it's fine. The E in progress error is, that's what it gives when it times out. When the connection times out. So there must be something wrong with the Wi-Fi. Usually you can just reboot everything and it works fine. But that's the first time I've had this problem. Usually it's pretty reliable. Let's stop it. Anyway, I'm going to investigate that. And then post things and you can use this code to do whatever you want.